Hi everyone, now we are performing an experiment that is resonance in LCR series circuit. Let me explain the circuit diagram first. So this is a circuit, here this is AFO, then this is AFO, that is audio frequency oscillator, and milliammeter, it's an milliammeter, and resistor, resistance box, inductor L, this is an inductor, and capacitor C, this is the capacitor. These two are this is fixed inductor and this is the fixed capacitor, where these two cannot be varied, and its value is already written here, 50 millihenry, and here it is, you can observe it, 1 microfarad this is. And at first of all, aim is to set up an LCR series circuit and study the resonance and determine the resonant frequency of the circuit to determine the quality factor of the two different values of the resistor. Let me explain you. At first, we have to take for the 20 ohm of resistance. So now I have picked it 20 ohm. You can see it, observe carefully. And these are the formulas for resonant frequency. F naught is equal to 1 divided by 2 pi into root of LC. It will be in the order of hertz only. And bandwidth, we know the bandwidth is the difference between the highest frequency and the lowest frequency, where F naught is the highest frequency, this F1 is the lowest frequency. It's also in the hertz. And this is quality factor, that is omega naught L divided by R, where omega naught is equal to 2 pi F naught and L remains constant, L divided by R, where the quality factor is defined as the sharpness of the resonating curve, or it is the it is the ratio of the inductive reactance or capacitive reactance to the resistance. And this is a circuit. I have already made the connections. Let me explain you again. This AFO, from AFO negative, so AFO to the one terminal connected to the negative of the milliammeter, this one terminal, this AFO wire, one terminal, this red wire is connected to the milliammeter, and again another one wire connected to the resistance, and this again resistance is connected. This is the ground and we should not connect it here, and here we are not getting the any positive negative, so that this is one terminal connected to the inductors another end, and another one terminal to the inductors another end to the capacitors, and capacitors another end to the again AFO, this type. And this is the nature of the graph, where R is the resistance box, L is the inductor, C is the capacitor, and this is the nature of the graph. By observing this graph, we can say that when frequency is increasing, the current also increases. Now what we need to observe is, when we increase the frequency, the current also increases. There the maximum current, this maximum current is known as the I maximum, and this is the root mean square value of the current maximum, that is I maximum divided by root 2. This is the F1 or F2. Then these two are known as the lower cutoff frequencies. This is a higher cutoff frequency. For the bandwidth, what I need to do is, I need to minimize it, F0 value, this highest value minus the minimum value, this value or this value. I will get the bandwidth. Then observations, the resistance is 20 ohm and 50 ohm. For the first reading, we are taking for the 20 ohm resistance, and the inductor is 50 millihenry, already we know that, and capacitance is equal to 1 microfarad. Then what we need to do is, for 20 ohm resistance, yet first we have to pick up for the 20 ohm. Before I will start an experiment just by turning on my experimental setups. So before that, I will take it for the input voltage is 2 volts. By using this knob, we can increase or decrease the voltage. So what we need to do is, we have to fix it for the 2 volts, then it's fixed. Then here for VPP, we can see it carefully, VPP, that is voltage per peak to peak. This is the peak to peak voltage, and if you persist again, we can observe it by the carefully this small knob for the VPP, that is voltage for peak to peak, and this bigger knob for the frequencies. This is 0.1, 1, 10, 100, 1K, 10K, 100K, and 1 million. These are the frequency ranges where I need to apply for this, and this red blinking light shows for the in which order we are measuring. And this is for the sources. Now I am giving for the AC source sorry, sine wave, this is a triangular wave, and this is square wave, and this now for the fine adjustment. Now what we need to do is keep it for the 100, and observe by increasing the pulses. For the 100 hertz, yes, for 100 it is showing 0.3 milliamps, and take down here for 100 hertz, this is 0.3 milliamps current. And then for 200 press for 1K, and before going to that, decrease it for the 0 and increase. One 96, 197, for 200 it is 0.8, and note down as 0.8, and go on for increasing the 100, 200, 300, 400, 500, 600, 700, and for 800, and for 900, 1000, 1100, 1200, 1300, 400, up to 2000 hertz. Then later, note down for the currents in the increase, it will gradually increase around at the 700 hertz. I will show you for the 700 hertz. Now using the fine knob, I am setting it for the 7 hertz. It is showing 4 milliamps, 4.0 milliamps. Then for 800 it will be decrease. It will be 3.7. For 800 it will be 3.7. So this is the part first. This is for the tabular column 1 for the 20 ohm. Then what we need to do is remove the resistance box for 50 ohm. Here what we need to do is remove for the, here it is for the 50 ohm. So by removing the 50 ohm, then take for the readings. Now increase for the 10 ohms, 100 hertz. We have to do it for slowly, that is 0.3. For 100 this is 0.3. Then for 200 it is 0.9. For 200 it is 0.9. Then go on for the up to 700. Then here for the max and 2000 hertz, it will be having the some values at. First of all ಏನು ಮಾಡ್ತೀವಿ ಅಂದರೆ ನಾವು ಇದರಲ್ಲಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಸೀರೀಸ್ LCR ಸರ್ಕ್ಯೂಟಲ್ಲಿ LCRನ ಈ ಸರ್ಕ್ಯೂಟ್ ಯಾವ ಥರ ಇದೆಯಲ್ಲ ಅದೇ ಥರ ನಾವು ಪ್ರೈಮರಿ ಇನಿಷಿಯಲ್ ಆಗಿ ಮಾಡ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡ್ತೀವಿ, ಆ್ಯಸ್ ಪರ್ ದ ನೇಚರ್ ಆಫ್ ದ ಗ್ರಾಫ್ ನಮಗೇನು ಹೇಳುತ್ತೆ ಅಂದರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇಂಕ್ರೀಸ್ ಆಗ್ತಿದೆ ಅಂದಾಗ ನನಗೆ ಕರೆಂಟ್ ಕೂಡ ಇಂಕ್ರೀಸ್ ಆಗ್ತಿದೆ. ಒಂದು ಸಡನ್ ವ್ಯಾಲ್ಯೂಲಿ ಯಾವುದೋ ಒಂದು ಸರ್ಟೈನ್ ವ್ಯಾಲ್ಯೂಲಿ ನಂಗೆ ಆಲ್ರೆಡಿ ಎಕ್ಸ್ಪ್ಲೇಟ್ ಮಾಡಿರೋ ಪ್ರಕಾರ ಇಟ್ಸ್ 700 ಹರ್ಟ್ಸ್ಗೆ ನನಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕರೆಂಟ್ ಬರುತ್ತೆ. ಸೊ 700 ಹರ್ಟ್ಸ್ಗೆ ನನಗೆ ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕರೆಂಟ್ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ, ನನಗೆ ಕರೆಂಟ್ ಕೂಡ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆ. ಇದು ನನಗೆ ಸೀರೀಸ್ LCRಲ್ಲಿ ಬರ್ತಿರುವಂತಹದ್ದು. ಏನು ಮಾಡಿದ್ದೀನಿ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ನಾನು ನನಗೆ ಆಡಿಯೋ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಸಿಲೇಟರಿಂದ ಒಂದು ಟರ್ಮಿನಲ್ ನಾಬ್ನ ಮಿಲಿಯಮೀಟರ್ ಎ ಸಿ ಕೊಟ್ಟಿದ್ದೀನಿ, ಇನ್ನೊಂದು ನಾಬ್ನ ಕೆಪಾಸಿಟರ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀನಿ. ಕೆಪಾಸಿಟಿ ಕನೆಕ್ಟ್ ಮಾಡಿ ನೆಕ್ಸ್ಟ್ ಒನ್ ಟರ್ಮಿನಲ್ ಬೈ ಎಂಡ್ ಟು ಎಂಡ್ ಕನೆಕ್ಷನ್ನ ಮಾಡ್ಕೊಂಡು ಏನು ಮಾಡಿದ್ದೀನಿ, ಸಿರೀಸ್ ಸರ್ಕ್ಯೂಟ್ ಕನೆಕ್ಷನ್ಸ್ನ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಸೊ ಬೈ ಇನ್ಕ್ರೀಸಿಂಗ್ 100 ಓಮ್ಸ್ 100 ಹರ್ಟ್ಸ್ ಅಷ್ಟು ನಾನು ಫ್ರೀಕ್ವೆನ್ಸಿನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಿದ್ದಂಗೆ ನನಗೆ ಮಿಲಿಯಮೀಟರಲ್ಲಿ ಎಷ್ಟು ಕರೆಂಟ್ ಬರ್ತಿದೆ ಅಂಥೇಳಿ ನೋಟ್ ಆನ್ ಮಾಡ್ಕೊತ ಹೋಗ್ತಿದ್ದೀನಿ. ನೋಟ್ ಆನ್ ಮಾಡಾದ್ಮೇಲೆ ನಾನು ಗ್ರಾಫಿಕಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡ್ದೆ. ನನಗೆ ಆ್ಯಸ್ ಫರ್ ದ ಗ್ರಾಫಿಕಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ನನಗೆ ಈ ಥರ ಗ್ರಾಫ್ ಕಾಣುತ್ತೆ. ಎಕ್ಸಾಕ್ಟ್ಲಿ ದ ಗ್ರಾಫ್ ವಿಲ್ ಬಿ ಲೈಕ್ ದಿಸ್.